is that?
Welcome everyone. So today I'm going to show you guys a program I made in Java that prints the Pascal's triangle, but as you've probably already seen, it stops working properly after a given point. First, I'll show you how I built the program and then why it crashes. Let's begin. So in order to understand how the program works, we first have to understand this formula right here, which is the backbone of the whole program essentially. This is the binomial expansion theorem. And what it does is it gives us the polynomial of the binomial a plus b raised to the nth power. So for example, when we have the binomial a plus b raised to the 0th power, we get an answer of 1, assuming that a plus b is always greater than 0. I just have the coefficient of this term right here written outside in the brackets, so it's easier to see, and you'll see why later on. When a plus b is raised to the 1st power, we get this binomial, a plus b, with again the coefficient of 1 on each term, and I just put them outside the brackets. Raising it to the 2nd power gives us this trinomial. Raising it to the 3rd power gives us this polynomial. Raising it to the 4th power gives us this polynomial as well. So we can see that just by writing down the expanded form of the binomials raised to all of these powers, we kind of have something that resembles a triangle. But it's only when I highlight just the coefficients do we see something interesting. Together, they make up the Pascal's triangle. Now, let's break down the equation to see how this happens. So, this part right here gives us the coefficients, which were the highlighted numbers that you just saw, which make up the Pascal's triangle. And this part right here gives us the powers of a and b on each term. Since only the coefficients make up the Pascal's triangle, right, we can completely disregard this part because we're not really calculating the values of a and b or whatever they are. And so we can just like completely delete it, right? All we did here, we're left with this incomplete equation. We just got rid of this part. And from a mathematical perspective, right, this is complete blasphemy. Like, you can't really have an incomplete equation like this. But in programming, we can literally just take whatever we need. And this is essentially all that we need, right? All this is doing right now is calculating the coefficients for each term in the polynomial a plus b raised to the nth power. This Greek symbol here means sigma. And it's called sigma, and it means basically the sum of from a mathematical standpoint, but from a programming standpoint, it acts as a for loop. It has a start point k, which is initiated at 0. It has a condition at the top. In math, this is called an index, but an index in programming is something completely different. It's kind of misleading, so we'll just leave this as the condition here. This n is the same n here, which is the power of the binomial a plus b, and the start point k increases by 1 each time until it reaches this condition right here. So it will keep running so long as it is less than or equal to the condition at the top. This right here is the rule of the sigma, but from a programming perspective, this is basically just the code that's inside the for loop. We're just manipulating the variables n and k each time that k is a different value. In math, this part right here is read as n choose k. This is not directly part of the sigma. This is just a rule which happens to be part of this equation, or this incompleted expression right now. This is basically just this formula right here, which is derived from a branch of mathematics called combinatorics, and deals with combinations and permutations, which is way beyond the scope of this video. But now you can see that we have actual mathematical operations like factorials, division, subtraction, multiplication to work with, and we can replicate that in our program. So let's start by assigning n the value of 0, which means we're raising the binomial a plus b to the 0th power right here. Because k is equal to n in this case, the rule only runs once with these values, and so when we evaluate this, we get this one single coefficient right here. It's the purple coefficient right here. Now, let's say that n is equal to 1, and this is what our equation will look like because n is now greater than k in this scenario. The rule will run when k is equal to 0, and we can see the values of k and n have been substituted into this equation again, and then it will run again this whole thing when k is equal to 1, and we'll see that in a second. So when k is equal to 0, we substitute the values and we get our first coefficient of 1. Keep in mind here that the a is just for reference, as it's not actually printed with our incomplete equation. It's just to show you the coefficient a little bit better. The purple coefficient here is what we actually care about. And now when k is equal to 1, the rule runs again because k is still less than or equal to the condition at the top, right? So we substitute the values again and we get our second coefficient, which is also happens to be 1. Again, the letters are just for reference. because we cannot increase k any further, right? Because the start point cannot be greater than the condition, our expression has been simplified into its lowest terms. So in a general sense, we can kind of conclude that this expression basically just prints the numbers in the n plus 1th line of the Pascal's triangle. So what I mean is that when n is equal to 0, right, this whole expression right here gives us the first line of Pascal's triangle with the coefficient of the 1. And when n is equal to 1, it will give us the second line of Pascal's triangle. When n is equal to 2, the expression will print the third line of Pascal's triangle, and so on. So this small discrepancy will come into play later on, but now that we actually understand how my program is calculating all of these values and what is really behind all of this stuff, we can move on to the actual code and see how it works. Alright, so here we are in Eclipse, and this is my program. It's just condensed right now, right? So because there isn't a factorial method in any of the Java libraries that I know of, I had to make my own method to get the factorials of the numbers so we can plug them into our expression right here. And basically when you open it up, it's just a small block with a for loop that iterates through all the numbers from 1 to the factorial number and then just multiplies them together and then returns a value. But this method right here though, print Pascal's triangle, is what is actually giving me all of the coefficients. So opening it up, you can see it's a bunch of code right here. So first of all, we ask for the user input. With the scanner class, I just print out a line and I assign that to this long variable n right here. Now the reason I'm subtracting 1 is because of the discrepancy I mentioned earlier. So if they want to print the first line of Pascal's triangle, right, they have to input 1. But because n has to be 0 in order for it to print that first line of Pascal's triangle, I have to subtract 1 from that value. And this applies to every number that the user inputs. So it's just making sure that whatever number that they input and that I'm using in my expression aligns correctly. This value then goes to this for loop right here, which is basically our sigma. We can see that it has a variable k as its start point, but you can probably also see that we're not using the variable n as a condition, we're using I as a condition. This is because if I use n as a condition, then only the nth line of the Pascal's triangle will be printed, right? If I have one single value of n, it's only going to print the nth line. It'll give me the coefficients for just the nth line of Pascal's triangle. But because we want to print all of the lines of the Pascal's triangle up to n, or that value that the user inputs, we have to iterate our whole expression for all of the values below n. This is why we have an outer for loop right here, which has its own start point of 0, and it keeps iterating so long as it is less than or equal to n. We can see that this I right here, where n is supposed to be, is actually this I right here, right? So basically we're just substituting n for this I variable, and then it will run this line right here, which is basically just this part of our equation, right? The factorials is what's actually going to give us the coefficients. And once it has been calculated, it will print out whatever the coefficient is with a little space to make sure everything's organized. Then it'll print a new line for the next set of coefficients to be printed. And that's basically how my whole program works. So we can see it running. So it will ask the question, enter the line that you want to print the Pascal's triangle up to. We can start off small. We'll start off with 10 lines of Pascal's triangle, and it'll print them like this. And then we can try with actually a larger value. So let's try something like 15. It'll print the 15 lines of Pascal's triangle. It'll print out, so let's say 20. It'll print out the 20th line. But what happens was, when I inserted the number 30, like in the beginning of the video, it got all messed up right there. So the first thing you want to notice is that it gets messed up after the 21st line of Pascal. So even though this is 20, it's actually the 21st line of Pascal's triangle. So the 22nd line of Pascal's triangle and all the lines after that, they get all messed up. And we can try with actually different values. So let's try with the value something like 33. So even still, you can see it get messed up at the second line of the Pascal's triangle. Alright, to understand why this is happening, first let's look at the maximum value a long variable in Java can hold. A long is a 64-bit primitive data type that can hold a maximum value of around this, or approximately 2.223 times 10 to the 18th as an integer. So when we run our program, right here, and we insert the number as the user input as 22, what's happening is this n variable right here is going to get assigned the value 21, right? Because we're subtracting 1. And inside this for loop, when I eventually reaches n, or when I eventually reaches 21, this line of code will be executed inside the smaller for loop. And we can see here that it's calling the factorial method with the parameter I. So it's basically calculating the factorial of 21. And it just so happens to be that the factorial of 21 is equal to approximately 5.12 times 10 to the 19th, which is greater than what the long data type can hold. And basically what that means is all of this gibberish that you're about to see right now, this line here with all these negative values, is just the result of something called overflow in Java, which includes a bunch of weird calculations to give us this result. Again, way beyond the scope of this video. And this also means that any line printed after this will have the same result. So anything greater than 22, like again 30, it will give you all this gibberish. 50, even more gibberish. And at some point when it gets too big, we insert something like 100. We get this exception here and it just stops working. So now you basically know how my program works and why it suddenly stops or messes up at that certain point. I've actually linked a website in the description where you can find other people's code to print the Pascal's triangle, and they have much more efficient programs than what I have here. They're actually able to print up to 500 lines of Pascal's triangle because their programs are dealing with much smaller numbers compared to mine. And so they're able to manipulate them for longer and they don't have to worry about the problem of overflow. Alright, so I hope you guys enjoyed the video. It was actually really cool to show you all of that math and seeing how my program, just died after a certain point. And yeah, I guess that's about it for today. I'll catch you guys on the next one.